Hello and welcome back to Mac's Runout. My name is Paul. The last series of videos I've been doing had to do with injection molding plastic parts and using recycling actually containers and so on to make them into new kinds of parts. And I do have several more videos planned for that series, but I'm having a bit of a diversion today to talk about another little trick that I learned or thing that I've been doing that has to do with restoring antique machines. I've restored a number of the machines that are in my shop, and also starting about 10 years ago, I've restored a number of antique tractors as well. And it's an interesting project, and it's fun to recreate these old machines and learn how they worked, and I really enjoy it. But one of the things that happens if you're going to restore an antique machine is you end up with a lot of rusty bolts, and cleaning up the bolts is a chore, and there's a lot of ways to do it. I suppose you could try to use solvents and what's the right term? Electrolysis. And if you got a bead blast cabinet, you're in good shape. You could do it with those, but not everybody has that. And actually, my favorite way of cleaning them up is just to use a wire wheel on a bench grinder. Now, you don't necessarily have to clean them up. One thing you can do is buy some shiny new ones at the hardware store, and that's a solution. But if you're fussy about how your equipment looks, you can see from this picture. You know, some of the heads on the bolts aren't really the same. The head on the one on the right is the original one, and that is substantially thicker than the one from the hardware store. And also, as you can see from this photo, not all the bolts are easy to find. Some of them have square heads and or special heads, or various special kind of fasteners that are really hard to replace. So the other thing is, last time I checked, the hardware store wasn't giving them away. So the approach that I've come up with that works best for me is to clean up the bolts by running them against a wire wheel in a grinder, and I'll show you a little bit about that in this next segment. If you're working on a big guy like this, it's not a problem. It's easy to do and does a good job of cleaning up all the rust and paint, whatever, off of it. But you also get a lot of little guys like this, and trying to hold one of these tight against the wheel and clean out all the spots under the head and so on is I can't see that. Yeah, is difficult. It's a pretty good way to turn your fingers into mush. This is even a better example of something that would be just about impossible to do on a machine like this. So I wasn't too crazy about the idea of turning my fingers into mush, and so a solution that I came up with a number of years ago when I was working on the tractors was I had some scrap pieces of aluminum here. These, I think, are rollers from a Xerox machine or something like that. I found them at a surplus place. They're aluminum, and what I did was I drilled and tapped each end to hold a specific kind of bolt. And this case, this is a 3/8. Whoops, wrong end. There. No. Had it right the first time. This is a 3/8/16 bolt, and what I did was I cut the threads in here only a few threads deep, so that when you turned the bolt in, it jammed after a couple of rotations. And now you can hold this on the bench grinder. You can get a hold of it with both hands, and you can put it on the surface of the bench grinder and turn it, and it really does a great job of cleaning it up. It's a simple trick, but it really saves you a lot of time, and it makes things much easier, and you get the bolts looking the way you want them to. So I got a couple of clips here where I'm going to show you what the process is, how I did this. It's certainly not the only way to do it, but I've got a lathe, and it made it easy to do this drilling and tapping operation on the lathe. And the reason I'm doing it today is that this idea has become popular with some of my friends, and a number of people have asked me if I would make a set for them. So I'm making 3 sets today, so for some friends of mine that would like to try this idea too. So here's a clip on how I made them. Okay, step 1 is going to be cutting the stock to length, and for that we're going to use a horizontal bandsaw. Could be you could use a hacksaw for this job, but especially if you were younger and had more energy than me. But I made a little stop here, so we'll get them all approximately the same length. This sets the end of the piece, and we just turn it on and cut it off. I'd use a blade with coarser teeth, and it would go through much quicker. This is a real fine-tooth blade, good for cutting steel, but changing the blades in this dog is a real pain. So since I only got a few to do, we're going to go with the blade we got. Okay, we've got 6 lengths of stock pre-cut, and the next step is we got to put them in the lathe and machine the ends of the stock to hold the bolts. Okay, we're going to start by chucking up the stock in the 3-jaw chuck, leaving a little material sticking out to work on. And the first step is to face off the end so it's nice and square. We'll just touch off here. Lock the carriage, back it up, go in about 10 thousandths or so. This will clean up the end. It was just cut with a bandsaw. And us a nice square surface to start with. Next, we'll get the cross slide out of the way. First step is to use a center drill to give us, make sure we get a start dead square in the center of the of the stock. This will get the drill started right in the center and give it a pilot hole to start with. Now this part is being made with a 1/4-20 size bolts, and the correct pilot drill for that is a number 7 drill. So we'll chuck up a number 7 in the tailstock chuck here. I use WD-40 for cutting oil for aluminum. Works pretty well. And we'll go ahead and I'm going to drill this hole about an inch deep. An inch is not really necessary for now, because we're only going to thread it a few threads deep. But if the part gets worn out, or if you're working on a long bolt and you mess up the threads, you can go a little deeper. No problem. We'll have plenty of depth in the hole. When you're drilling a deep hole like this, you can see the drill is doing a pretty good job of bringing the chips up to the surface. But as you get deeper and deeper in the hole, it's harder and harder for the drill to carry the chips to the surface, and so it's a good idea to back out every once in a while and clear the chips out. As we get almost an inch deep here, you can see the chips are not coming to the surface very well, and backing out just helps to clear them out. We're almost an inch deep now, and clear these out one more time. It's 9/10 of an inch, and that's 1 inch right there. Okay. Now the next operation is to tap the hole, and to do that, we're going to use, in order to get the tap going nice and straight in the hole, we're going to use a tap follower. It's a little spring-loaded gizmo. You can find these on the internet. That just helps you with that operation. This, well, you can't see it too well on here, but this tip here is spring-loaded, and it holds the tap in place. And make sure you get a nice straight start on the hole, on the tap. And I put it in just about all the way. See how nice that works? I'll lock the carriage in place, and then when we turn the tap, it'll follow it right in. And for this job, when you get just about to the end of the spring travel on the tap follower, you got enough. You don't want to go too much deeper than that, because then when you're using this thing to clean bolts, it'll be too far in. So that's about it right there. And we'll back this out. I'm using a 2-flute tap here, which is a little different than the ones you find in a hardware store. That'd work fine too, but when you use one of those taps, you got to constantly be going backwards and forwards to clear the chips. This one is a 2-flute tap, and it's got a tip on it. It's called a spiral point tap that pushes the chips forward, and it's in focus better there, I guess. Pushes the chips forward, and so you don't have to keep going back and forward. It's suitable for power tapping, although we're not doing that in this operation. Okay, we got most of the important parts finished here. We got a 1/4-20 hole tapped in the end of here, so that we can drilled and tapped, so that we can accept the bolt that we want to clean up. But a couple more additional things we want to do. First of all, we want to put a taper on this hole, so it's easier for the bolt or easier to get the bolts in there when you're changing them quickly. So do that first. It works to just hold your countersink in there, and that'll do the trick. And the other thing we want to do is the bolt. This shaft is 3/4 of an inch in diameter, which is pretty handy for holding on to. You can get a good grip on it when you're trying to clean the bolt up in the wire wheel. But you'd like to be able to get up a little closer to it with the wheel here, so it'd be nice if this diameter was smaller. So we're gonna go back about 3/4 of an inch. Don't need this kind of precision, but this is the instrument I got handy. I'm going to go back about 3/4 of an inch and make a mark on here, so we know where to stop when we're turning this down. Right there. And we'll just turn this down a little bit so that you can get it in there better with the wheel. Okay, touch off here. We'll go in about about 50 thousandths at a time, I guess. I'll put my And finally, we want to just chamfer these corners, knock off the sharp corners. A little hard to see, I guess, what I'm doing here, but I'm just putting an angle on these corners. Okay. So that's that end. That'll do the quarter 20 bolts. I'm going to turn this around and now work on the other end. Okay, now we've got the stock switched around and reversed, and this end is going to be done for a 5/16 18 part here, bolt. So we've got the pilot hole drill put in, the stubby drill, and we're going to start with that, and then we'll be drilling a main hole with a letter F drill. It's a .257, a little bigger than a 1/4 inch drill, but that's the right tap drill size for 5/16. Okay, we got the letter F drill in there. We're a little up a little closer now, so you can see what we're doing. Again, we're going to go about 1 inch deep. And like before, it's a good idea to back out once in a while and clear the chips. That's 1 inch right there. And again, we'll go in with the tap. Nothing too exciting there, so I think we'll do that off camera. Couple comments about the tapping. One of the reason I have these spiffy taps is because I was at a swap meet and I found a guy selling off some machine tools, and he had a whole box of taps, and most of them were dirty and worn out, and some of them were pretty rusty. But I looked through the box and I found a number of taps that were near new or brand new, and I got pretty excited about that, and so I bought the box for $10, and it looked like junk, but like I say, buried in the junk were some jewels, and some of those jewels were actually these two flute taps. They're probably more expensive than anything I would have bought new from a machine tool catalog, but it never hurts to keep your eyes open at the swap meet. Sometimes you find some real treasures. Oh, and one other thing, these taps work fine for power tapping. Like I say, they push the chip forward, and so if you drill your hole deep enough, you can run the lathe and just do power tapping. And the only reason I'm not doing that now is because I only want to go in a few threads, and when the lathe is turning, it's pretty hard to stop on a dime there, so I'm doing these by hand. Okay, when I come in and turn the diameter down, maybe not quite so small as last time. We've finished 3 sets of these now. The ones on the right hand side, the end facing you, is for quarter 20 bolts, and yeah, in metric that's a little more than 6 millimeters. the end facing away from you on the right hand side, on the right hand units, is for 5/16 18 threads, which is about 8 millimeters. On the three units on the left, the side facing away from you is 3/8 16, which is about 9.5 millimeters, and the ones facing you are half 13, which are about 12.5 millimeters. So we're gonna, in the next segment here, we're gonna show these guys in action. Okay, here we go. I sound a little funny because I got a full face protection on here. It's really important when you're using a wire wheel. Wire wheels turn really fast, and the little wires can break off of there and shoot out like a missile. I've had them buried in my skin more than once. So I wear an apron and I wear the full face helmet when I'm doing this. I got a rusty bolt installed in our new holder here, and about to get started. There we go. Looks like a new one. So there you have it, a nice clean bolt, ready to install and paint or whatever as you restore your machine. Normally I would work from the other side of the wheel there, but the camera was in the way, so I had to work from this side rather than this side. Then if you work on the right side of the wheel, on the right side of the grinder, then you can get up under the head better, and it's a little easier to use. I wasn't quite used to working from that side, so. But anyway, I think you get the idea. I think you'd find this a pretty handy addition if you do any restoration work at all. And no, I'm not in the business of making and selling these. I'm just giving you an idea here. If you want to do that, more power to you. But I just do it for pleasure, and I'm not really in the business. So good luck with it, and I'll be back with another video shortly. Some more on the plastics, as I said, and then I got a few other tips too that I want to share with you. So thanks for watching. If you're interested and you like what you're seeing, please leave me a comment. Or if you'd like to see something different, leave me a comment too, and I will try to do what people are looking for. Thanks.